Hello, Math 5a students. Today we're going to do a trig word problem. So this was actually on some review word problems with a handout with a link that's posted on Latte, so you can go find it. And if you want to try this problem before I go over it, you should stop the video right now and go try to do it yourself, and then you can come back and watch the video and compare to how I did. So this is what the handout looks like in general, and we're going to do this G29 solve a word problem that involves trig equations. So if we scroll down to the bottom, there's this problem about beetles. So it says a scientist studying a species of beetle measures the population size over an 8-week period and finds that the beetles have an 8-week long cycle modeled by this equation, where P of t measures the number of beetles after t days. So here's our variable t. And the first question is, how many beetles will there be after 30 days? So they've given us this formula, and P tells us the number of beetles, and T is our number of days. So we're just going to plug in 30 for T. So this is P of 30. We can double check our units. So T is days, and we're doing 30 days. So that's all good. So P of 30 is going to be minus 2,000 times the cosine of pi times 30 divided by 30 plus 5,000. And everybody loves to cancel, so we can cancel these 30s. And we are now computing, cosine of pi, right? So this becomes minus 2,000 cosine of pi plus 5,000. And if you remember cosine of pi, so remember cosine is the x coordinate of on the unit circle, right, of the point corresponding to that angle. So if you think back to our unit circle, pi is rotating halfway around. So we're over here at this point, which is minus 1 comma 0. And cosine of pi of this angle pi, a halfway rotation, the cosine is the x value, so that's minus 1. So this is equal to minus 2,000 times minus 1 plus 5,000. And that's minus minus is plus, so this is 7,000. So for part A, there will be 7,000 beetles. That's a lot of beetles. There will be 7,000 beetles after 30 days. Okay, and then part B, they want us to know, tell us when will the population first reach 6,000 beetles. So now they're giving us the population and they want to know the time, when, right? So here we're plugging in 6,000 beetles for P, the number of beetles, and we're trying to find T. So we want to go the other way. So for part B, we have 6,000 equals minus 2,000 times cosine of pi T over 30 plus 5,000. So we want to solve this equation. So we're going to first subtract 5,000 from both sides. So this is 1,000 equals minus 2,000 cosine of pi t over 30. So we can divide by minus 2,000. So we get minus 1/2 equals cosine of pi t over 30. Okay, so this problem right now looks pretty hard. And so what we do in math or in any kind of problem solving ever is when we say, oh, this problem looks really hard, so I'm going to solve, it's too hard. I'm going to solve an easier problem first that's related, that's hopefully going to help me figure it out. So what we're going to do is we're going to say, okay, I don't know how to figure out what T is from this situation, but I can figure out when is cosine equal to minus 1/2. So, right, this is just solving our basic trig equations where we're going to we're just replacing this complicated inside part, pi t over 30 by theta. So it's really nice if you also give yourself a little note, or the person who's reading your work, to say, oh, well, we're going to let theta be equal to pi t over 30. We're taking the complicated part and we're just replacing it by this value theta so that we can think, oh, what angles can I plug into cosine to get -1/2? So, when I think about this, I'm like, oh, my trig values, 1/2 is something that comes out of our 30, 60, 90 triangle. Maybe you've used the chart method or the hand method or just memorized values on the unit circle. But however you figure out your trig equations, we're going to do that. So I'm going to go over here to the side and say, okay, well, I remember my 30, 60, 90 triangle, right, is 60 degrees, which is pi/3 or pi/6 for 30 degrees. And I have 1 and 1/2 and square root of 3/2 on my vertical side over here. And so I want cosine is the adjacent side. So I want this 1/2 value, and cosine of pi/3 is going to give me a +1/2. So that's what this is telling me. Cosine of pi/3 is giving me +1/2. And then if we think about our unit circle, so pi/3, we get up here, right? This is like pi/3. It gives me +1/2, but I want my cosine to be negative. So as I'm traveling around on my unit circle, the first time I hit +1/2 is at pi/3. I keep going in that same direction because I want to hit the first time that I get to 6,000 beals. So the first time that I get to a -1/2 on my cosine, right, my cosine is negative over here in this quadrant because cosine is the x value. So the first time it's going to get to -1/2 is at 2 pi/3. So over here at 2 pi/3, cosine of 2 pi/3 is -1/2. So if I go back here, that means that theta is equal to 2 pi/3. So that's nice that we found theta is 2 pi/3. It gives us cosine of 2 pi/3 is -1/2. But we're not trying to find theta, we're trying to find the time. So, but we know theta is equal to pi t/30. So we're going to set this theta equals 2 pi/3 equal to pi t/30 because they're both expressions for theta. So our next step, having a lot of space here, is to say theta is 2 pi/3. And that's also equal to my pi t/30, this green guy over here. And now I use this relationship to solve for t. So now I can say, all right, I'm going to multiply both sides by 30, or you can think about cross multiplying if you want. So maybe if you know how the idea of cross multiplying, it's the same idea. So we can multiply 2 pi times 30 is equal to the other cross, 3 times pi/t. So this is 60 pi on this side. And we're going to divide both sides by 3 pi to find t. So t is equal to the pi's cancel, and the 3 will cancel to give us 20. So t equals 20. And so we should write a sentence. So we say the population will first reach 6,000 beetles after 20 days. And just as a sort of reality check to make sure our model is working out, right? So we started out, if our t is 0, cosine of 0 is 1, so 5,000 minus 2,000 would be 3,000 beetles. We already answered in part A that after 30 days, we have 7,000 beetles. So after somewhere in between, from 3,000 to 7,000, after 20 days, we're going to get 6,000 beetles. So that seems to be making sense, which is good. We have our sentence. There was something else I was going to say that I can't remember right now. But yeah, so just using this idea that we can take a hard problem, make it a little, find an easier problem that's related to it, and then set these two values equal to each other to find the time. And that's how we solve these kinds of problems.